So I want to take a quick second to thank our gold sponsor, Vultr. Kind of a one-stop shop for all your cloud servers, storage, now even bare metal servers, just really fast, really high performance, really cost effective, compatible with Laravel Forge. So I know most of us are probably Forge customers, and you can spin up Vultr servers right from there. So definitely check them out. Huge sponsor of Laracon Online, really made a lot of this possible, a bunch of free tickets possible. So a big thanks to Vultr for sponsoring Laracon Online. Okay, and now I'm going to stop sharing, hopefully. Okay. All right. How you doing, Marcel?
Hey, I'm doing great.
Great.
You can hear me? That's good.
I can hear you. So you can go ahead and share your screen whenever you're ready, and we will chat at the end.
All right. All right. You can see my screen? Looks good.
We're good.
All right. So I'm going to talk about real-time applications with Laravel. And we're going to take a look at the different approaches on how you can achieve real-time applications and how you can make this work with your application, but also how you can apply real-time solutions to Laravel packages, and hopefully you get inspired from what you can achieve with this technology. So first off, a quick disclaimer, I got two cats. These are the cats. They have been on I Can Ask Cheeseburger, so they're famous, I guess. And they're currently sleeping. They're very lovely animals, but maybe they start shouting because I'm at home, so just relax. I got some audience here, so that's fine. So quick intro about me. If you haven't heard about me, my name is Marcel Pociot. I am working as a managing partner and developer at a company called Beyond Code. We're two people at the company. I started it 1.5 years ago. And we are helping our clients with Laravel-related solutions. So you can follow me on Twitter using the handle that you see here, and I tweet mostly about Laravel-related stuff. So before I had the company, I was doing a lot of open source, mainly in the evening. Now that I have my own company, I'm still doing most of it in the evening, but some of the things I can shift in the work hours as well. And open source is a really big motivation for me. I love to contribute things back to the community because we're just using so many open source tools that I feel like this is my way of giving something back to everyone. And so far, I've created more than 60 PHP packages, which are all open source, and a bunch of others in different other languages. They have more than 5 million downloads. I think it's close to 6. And the big benefit of this is because our Laravel dump server package was added to the core of Laravel. So thanks for that. So chances are that you've either used or seen one of our packages in the wild. So that's cool. And I quickly wanted to shout out another thing that I've built, which I think is really, really great and helps a lot of people, which is the Laravel Test Tools Chrome extension. And what it does is it's a Chrome extension that lets you record the activity on your website. So for example, when you're filling a form on your site, it records what you are typing and which checkboxes you click, etc. And then it generates a Laravel Dusk test case for you, or HTTP API test, which you can then just copy from there and use inside of your code. So it has around 60,000 weekly users. I'm not sure if Adam would approve this because it's not TDD, but a lot of people write more tests with this, so this is great. Okay. So about achieving real-time applications and how you can do this. Let's first take a look at some examples and ways of how we can add real-time behavior to our application. So the first thing I want to show is the more like traditional approach, I think, which is Ajax. So I have a very typical example here. It's a chat application. Yeah, I know this is like the #1 example when you talk about real-time applications, and I promise I'll show you something cooler later on. But just for the sake of this demo, chats will do just fine. And if I open the chat and take a look at the DevTools, this is what happens. So let me clear this. So with the AJAX approach, we are sending HTTP requests every second to our server. And we are asking the server basically every second, hey, do you have a new message for me? What about now? And what now? Because the client does not know if there are new messages on the server. So what else should we do instead of asking the server? And because we want it to feel real time, we have to do it pretty fast and quite a lot of times, so every second in this case. So if I just simulate a message, I just got a little command for this. So here we got the message, and then we can see it. As you can see, the delay, because it's not real time, is up to a second, and that's because we only ask the server for new messages every second. And this approach, besides not being real time, because we have this up to 1 second delay, also has some other problems, as you might see once we have the DevTools open. So one issue is that we are sending a ton of requests to the server that are simply unnecessary. So we are asking the server over and over again, and we don't receive a reply most of the times. Now, the problem is that those requests are, let's say, a kilobyte each, and that sums up quite a lot. So that's not much if it's just one single request, but for all the requests that we have, that's quite a lot of data that we have to transfer. We have the overhead of HTTP headers. When we make the request, we have to perform a DNS lookup. All these things really make AJAX slow, at least for this specific use case. So don't get me wrong, AJAX requests are a great way to perform asynchronous tasks, but it might not be the best fit for a real-time application, such as a chat. So let me clear this. OK. So the next solution that we have is long polling. So let me open the chat. And if we take a look at the DevTools, we still see one HTTP request, but now it's a bit different. With long polling, instead of asking the server every second from the client, we just send one request, and the server is then trying to keep the request open for a long time. And now, instead of the client asking the web server if we have new messages, our server is now internally asking the database every second, do you have something new? Do you have something new? Do you have something new? And if it does, we get the response. And if it doesn't, then you can see that here. The request times out. And then the client is starting this request again. So if we now simulate another message, you can see that our long polling request gets finished because the database check that we perform every second notices that there is a new message, and we get the response. And then we ask the client, the server again, for a new message. So even though in terms of HTTP requests that we send to our server, this is a lot better than with the AJAX variation, it's still not really that good. So in terms of real time, well, I think it's a bit better. But since we are polling and asking the database every second, we still have this up to 1 second delay. And even worse, let's imagine that you have a chat application with a lot of concurrent users. Then what happens with long polling in place is that your web server ends up holding all of these requests open just in case that we have a message at some point. So I think long polling, even though it's a possible solution for this, is also not the best one. So let's close this and clear this in here. And the next example would be WebSockets. So let's take a look at the same chat, but now built with WebSockets. We can still see some XHR requests. Those are from Laravel Echo in this case, so we can ignore them. But the more important part is that we now have a WebSocket connection. And if I take a look at this WebSocket connection, then we can see the individual frames. So this is the individual messages and pieces of data that get sent from the client to the server and back. So with this approach, if I simulate a message, we can now see that the message is coming in. But at the same time, we are not performing any additional XHR requests, but instead, we have these new frames coming in into our WebSocket connection. So this actually makes it a lot faster because we do not have all of this HTTP overhead. Okay, so let's take a look at how this works internally. WebSockets are defined in the RFC 6455, which means that WebSockets itself are its own full-blown protocol. And the reason that WebSockets are so fast is because they support full duplex mode. So that means traditional HTTP requests are only half duplex. This means that we have a communication in both ways, so from the client to the server and from the server to the client, but only in one direction at the same time. Whereas with WebSockets, as a full duplex mode, we have connection between the client and the server and the client in both ways at the same time, which makes it so incredibly fast. So here's how the flow of a typical WebSocket connection looks like. So we have some browser or client that wants to connect to a WebSocket server, and the connection is being established by performing a handshake. We'll take a look at that in a second. Once the handshake is approved and approves that the client connects to the server, we have a persistent TCP connection between our client and the server. And over this open connection, we can then share messages back and forth between the client and the server. And once either the client, for example, leaves the website that has WebSockets in place, or if for some reason the server dies, the connection gets closed. So the important part is that once the connection is established, we have this permanent connection in place where we can send data along. So let's see how the handshake for a WebSocket connection works. Funny enough, it's still a traditional GET HTTP request. So we perform a WebSocket connection by making a GET request to the WS protocol endpoint for a WebSocket connection. And then the client is basically telling the WebSocket server that it wants to upgrade the connection it currently uses to a WebSocket connection. And then the client is sending some additional headers. So you can see these SEC WebSocket key. Don't get confused. It's not about security in this case. So it's not authentication or anything. It's just to verify that the client actually wants to connect to a WebSocket server and nothing else. Then we can also support different sub-protocols. So you could add a list of different sub-protocols that your implementation supports, and then the server could reply, hey, I'm using this as well. And that's basically the request that we do send to our server. And the response looks something like this. So it's basically just telling the client, all right, go ahead and switch from HTTP to the WebSocket connection with the status code 101. And from that point on, we have this permanent TCP connection that we can use to send data from either side to each other. And the data is not limited to being text only. So you can also send binary data over WebSockets. And the browser support for WebSockets is really great too. So all major browsers support WebSocket except for Opera Mini. I have yet to meet one person who uses Opera Mini. So if you are that person, then tweet at me. But all the other major browsers support WebSockets. So I think it's safe to say that you can add WebSocket support to your application unless you are one of the pity ones that have to support Internet Explorer 10. I don't know if people still exist that have to do this. I hope not. Okay, so now that we have talked about how the technology itself works, let's talk about some use cases for WebSockets. So as I said, I want to show you some things beyond the typical chat application. Now, this is from your favorite server provisioning system, Laravel Forge. And I recorded this as a video because it makes things much easier. What I did before I recorded this video is I created a new site and then set up the site to use auto deployment. So whenever I push code to my remote on Git, then Laravel Forge is going to deploy my code automatically. And this is what happens if I'm going to deploy this. So I'm going to push the code up to GitHub. And if you watch at the DevTools, you can see that the server sends to the client these refresh events that we see in here. So what happened is that, similar to the chat example, where the client didn't know if there are new messages, what happened is that the server sent to the client, hey, refresh the user interface because I have some new information for you. And then the client can react to these events using JavaScript, for example, like it's done with Laravel Forge here. Another example is just a real fun one. This is a live streaming Twitter API that I built using WebSockets. So if you take a look at the code, this is, so tweet ahead and it'll show up in here. I'm sure we'll have some fun. So I have this Twitter command running in the background, which is constantly asking the Twitter API for some new tweets. And here's what the code looks like in Laravel. So this is the console command. I'm using the Twitter streaming API package from Spatie. Thanks again. I think you still need a postcard for me. Whoops. And all that I do is basically just initialize the streaming API. And on the public stream, when we hear one of these keywords that I've defined here, I'm emitting a new mentioned event, which is then being broadcasted over to the WebSocket server. And this then sends the data over to my browser, where you can now see the tweets coming in. Okay, another real fun use case is available at paint.dev.beyondco.de. So if you go there, and let me do this. Oh, okay. You're way faster than I am. So here you can just paint something, and then it gets streamed to all the other connected clients. And yeah, it seems to work great. So cool. All right. So have fun with that. And then there's something that I was really, really excited about when I first saw this being mentioned on Twitter. And this is Livewire. It's from Marcel Pociot. He built Livewire, and it's not yet available, but he gave me a little code to demonstrate for you. And let's first just take a look at the code and what at the site and see what it looks like. So if you take a look at it, it's basically just a traditional to-do app where we can have items, we can add new items in here, and they get stored. And then I can delete items, and then they get removed from my to-do list. So all pretty similar, but the real cool thing is that this is not using Vue.js, for example, or Ajax requests, but instead it's using WebSockets under the hood to talk to PHP components in your Laravel application. So this is what the underlying code looks like. So in here, we just have a to-dos route that points to this to-dos component. This to-dos component has some validation rules, and we have, just as you were supposed to have them on another class, public method, so add to-do, remove to-do, and a render method that has this blade file. And now the cool part is that you have this wire syntax. So the blade view is basically wiring the value of this input to the title property of my LiveWire component class. So after the title gets synced, we perform the validation. So if I just type something in, we immediately see the result. And then you have things like wire keydown.enter. Then we add the actual to-do, and this is now performing the add to-do method on our LiveWire component class. So Caleb recently tweeted that he feels like he's rewriting Vue.js for PHP, and it really feels the same. But it is really amazing, and I can't wait to see what this is going to look like once it's released. So thanks again, Caleb, for sharing me the code snippet. And I think that this is one of the fascinating examples of what you can do with WebSockets that we have not yet really thought about that much. Okay, so I think we can agree that WebSockets are kind of cool. So let's create our own WebSocket server. Now, when I thought about WebSockets, I have to say thought because this changed in my mind, but so far I was just thinking about Node.js, because WebSockets, as they have this full duplex connection and they have this asynchronous feeling to it because they kind of are asynchronous, and PHP is not really known for being an asynchronous programming language. So if I want to build something with WebSockets, I'll grab Node.js for this. So this is a typical, very simple example of how a WebSocket server looks like implemented in Node.js. So we have a WebSocket server class object that we initialize. And as I've told you, we have this handshake that still takes place with an HTTP request. So we still have an HTTP server. Then whenever we receive a new connection on our WebSocket server, we are going to accept it. And then with this connection object that we basically have these event listeners where we can perform actions every time we either receive a message, so every time the client sends a message to the server, or when the connection gets closed. And this is basically a WebSocket server in a nutshell. And this is what the client implementation looks like. So we just use the WebSocket object that our browser gives us. And then we connect to the IP or the host and the port of our WebSocket server. And then again, since we have full duplex mode and we can send data both ways, we have the kind of the same event listeners on our client connection as well. So we can perform some logic whenever the connection is opened. We can perform logic when there are errors sending or receiving the data. And we can perform logic whenever we receive messages from the server. So, but what about PHP? I mean, Wes Boss is speaking here, but other than that, it's Laracon, and we want to talk about PHP, I think. So say hello to Wretched. Wretched is an open source package that is built on top of another cool thing, which is called React PHP. And React PHP basically gives you, as a PHP developer, the ability to write asynchronous, event-driven packages or code. So you can just require this using Composer requires, Cbode, and Wretched. And then this is what a very simple WebSocket server implementation looks like using Redshift. So we have this chat class that implements a message component interface that Redshift gives us. And then we have the same event listeners that we had in our Node.js example, but now we have them in PHP. So we can still perform actions every time a connection gets opened to our server, every time we receive a message, or every time the connection gets closed or we have some kind of error. And then at the bottom, you see this I/O server factory, which is just wrapping, again, the WebSocket server with an HTTP server running on port 1337. And then we call the run method on this thing. And then with this code, if you just put this in a PHP file and have the proper imports, you have a fully running WebSocket server. And the client, well, the client does not really care if the server is running on PHP or on Node.js or any other programming language. So it still works exactly the same way. And this is me when I first really thought about this, because this really blew my mind, because it allows me, I kind of tend to think about these things also in terms of package development. But what this does is it allows us to add a fully functional WebSocket server into an artisan command. So we can just build an artisan command, and then whenever we call this command, then we just start a WebSocket server and run this thing, and then we're ready to go without even having to install some third-party Node.js dependencies that install a complete dictionary or something else. So we can just get started with this right away. And I really think that this is something that we can leverage in upcoming packages some more. So one thing that I built using this technology is called the Dusk dashboard. The Dusk dashboard is highly inspired by Cypress.io. Cypress is a Node.js-based front-end testing framework. So you can just install it using npm. And what it allows you to do is similar to Laravel Dusk. When you start Cypress, so you write your tests in JavaScript. And once you're done, you can boot up Cypress. And then it's going to perform your tests in the browser. So similar to what Dusk does. But the cool thing is that on the sidebar, you can see the tests as they get performed in real time. So you can actually see what individual steps are being performed. And I thought this would be cool to have for Laravel as well. So let me show you what it looks like. So this is a Dusk dashboard example application. And if I just take a look at the source code in here for one of the tests, these are just standard browser tests that you see for Laravel Dusk in like this. So nothing fancy in here. We go to the register page, make some assertions, then type some things in fields, press register, and make another assertion that we're on a different path. The only difference is that the Dusk test case class is now extending the base test case that comes with our package instead of extending the test case from Laravel. OK, so let me start the dashboard and show you what it looks like. So you can start like this. And now what this command does is it starts a WebSocket server. And since WebSockets need HTTP, as we've learned, we also have HTTP routes on this thing. So here we have the dashboard route, which is on the Dusk dashboard server. Now, let me move this away. OK. Now I can press start tests in here. And if I look at my terminal, you can see that PHP unit is now running. And now I can see all the tests coming in real time, and I can see each individual step of the assertions being performed in real time as well. Okay. So now that this is finished, since we have stored and sent each individual test step to our Dusk server, what it allows me to do is I can just click on each individual step of my test case and then take a look what happened here. So for this, we visit the register route, we make some assertions, then we type something into the name field. So here we can see what was typed in there. We make some more typing. And for each individual step, I have the whole HTML that was rendered at the time that the browser performed this specific test. Then we press register, and we make an assertion that the path is /home. And yeah, that's the case. And we can also see that the user that we faked is the user that was logged in. Yeah, and all this is possible thanks to WebSockets, because if I would have used Ajax, for example, this wouldn't feel as snappy as it does with the WebSockets, where I can see the individual test steps coming in real time. Okay, so let me close this. So that's the Laravel Dusk dashboard. Now, this is what the dashboard internally sort of looks like. So as I've mentioned, we can add multiple routes to our application. So we have a /socket route, which is going to add the actual WebSocket server implementation. So this is where WebSocket connections will connect to. Then I'm going to create a new route, which is a post route that will point to an event controller. And then I can also add this events route, but this events route will then be available for post methods. So how this works internally is that PHP unit is performing the Dusk tests, and then the result of each individual test step is being sent as a post event to this post endpoint, and there I am going to broadcast the information to the connected WebSocket clients. So this is how the event controller looks like. Really simple. We only have an onOpen method that gets called once a HTTP request gets opened. And there we are just sending and accepting the request body, so the post body, and then send it to all the connected clients on our WebSocket connection. Okay, so now, until now, we've only talked about how we can make use of WebSockets if we build them from scratch and do the client side on our own. But Laravel has support for something that makes this whole lot easier, which is Laravel Echo. So if you haven't heard about Laravel Echo or haven't used it, this is one of the typical examples taken straight away from the documentation. And what we are doing for the client is we are joining a channel. So channels, you can think of this as just grouping for events that you can listen to. And inside of this orders channel, I am listening for an event called order shipped. And whenever we receive this event, I'm just going to log the name of the order. So like this, you could, of course, do this with just these event listeners and using the plain WebSocket object, but then it becomes a lot more work for you, and you have to implement these channels somehow and send data between the channels. So Laravel Echo in combination with servers makes this a lot easier. So if you want to get started with Laravel Echo, I think one of the easiest ways is probably by using a service called Pusher. Pusher is a paid service that offers a free tier. And it basically is a WebSocket server as a service. And one of the cool things of Pusher is that it gives you these statistics where you can see the number of peak connections that you have. You can see the number of total messages that you send throughout the day, and you can take a look at how you sent them through per minute, things like that. And what's also cool with Pusher is that you have this debug view. So when you send messages to your WebSocket server, you can inspect these messages in real time as they happen, and then even send things back from your WebSocket server back to the client. So that's really cool. And I really like Pusher. It's a great service. One issue that I had for a couple things is the payload size is limited. So the maximum payload that you can send from the client to the Pusher server is limited to 10 kilobytes. So if I wanted to build the Dusk dashboard using Pusher, this wouldn't have been possible because I am not allowed to send the whole HTML string over to Pusher because it's just too big. But other than that, the feature is really good to use. It has some limits on the number of open connections, but other than that, it's great. And the integration with Laravel Echo looks like this. So you just create the Echo instance and then tell it that you want to use Pusher as the broadcaster, and then give it the key of your Pusher credentials that you received. So really easy. Another way on how you can go and create your own Laravel Echo server is by using the Laravel Echo server. So especially, I mean, I'm from Germany, and when we are working with our clients and we build something, for example, for internal use, they don't want to end up having their data being sent to an American company that stores the information on servers that are in Ireland, I think. So you can change the location of where you want your servers to be for Pusher, but still, if it's just an internal tool for a company, I don't necessarily want to use a SaaS for this. So for these use cases, Laravel Echo Server is great. It's a Node.js-based server that you can just set up. It requires Redis, so it uses Redis internally to subscribe to events and then send them out to the connected clients and store these channels. And how you would use it is you just install the Echo server, then you initialize the Echo server in your application, which is going to create a config file for you. Then you add a new client. So the Laravel Echo server supports multi-tenancy, so you can have one server and multiple clients or applications that are allowed to connect to this single server and share each individual channels in there. And then you basically just start it, which is going to start the WebSocket server, and then you have a Node.js process running that you can use. And the Laravel Echo integration is also really simple. You initiate the Echo object, but then instead of using Pusher, you're telling it to use Socket.io as the broadcaster. So that's the front-end tool that's being used internally. And you point it to the host and the port of your WebSocket server wherever it's running. And then you're good to go. Now, this really got me thinking. So when I was working on the Dusk dashboard, and I noticed that you can have your own WebSocket server in a Laravel package and in a command, then why isn't this possible with PHP? So at the time I was working on the Laravel Dusk dashboard, I was talking to my friend Freek about this, and we were discussing that I was complaining that doing this with Ratchet is really not that easy, and the documentation, especially for the HTTP part, is not really good. And it's really a lot of work just to get started with WebSockets. So what we thought would be cool is basically have something like route WebSocket, then give it a name, and then point it to a controller maybe. So that's basically the start of what then became Laravel WebSockets. Laravel WebSockets is a package that Freek and I worked on for around 2 months last year in November and December. And it's available open source under my company's account. And it basically acts as a Pusher replacement. So it still supports Laravel Echo and has support for Pusher API. And all you need to do is do a composer require, and you're good to go. So to make use of our package, you would require it as you would do with any other package that you're used to. Then you run the migrations. So our package comes with support for statistics. So these are the migrations. You can turn that off if you want, but yeah. And then you basically just start the WebSocket server using PHP Artisan WebSockets serve. And the great thing about this is that you do not need any third-party dependencies. You don't need to maintain a Node.js process that gets run and keep running. Of course, you have to maintain the PHP process, but still it feels a lot lighter to me because I can just pull it in as a package and suddenly have WebSocket support available for my project or even for my other packages. Now I want to show you how the configuration for the package looks like. So in here, I have the WebSocket package installed. And if I take a look at the config file, this is what it looks like. So with our package, we also have multi-tenancy support. Instead of calling it clients, we thought that apps might be a bit better or clearer to understand. So here you can, in your config file, define all the different apps that you want to support with the WebSocket server. Now, one thing that was, or still is, I think, confusing for a lot of people that uses our package is that we have these pusher credentials in here, and they wonder, what do I need to put in there because I'm not using pusher? And the reason we did this, we talked about this for quite some time, Freek and I, is we just wanted to make the transition, if you are using pusher, a lot easier so that you can just switch to our package really easy by keeping your pusher credentials in place and then just use our package right away. So all of this is just to make the transition easier. All of these can be replaced by just random strings. It doesn't have to do anything with pusher at all at this point. So I hope this makes some things clearer. And then you can enable statistics per client. You can enable client messages per client. You can also swap out how the package should load apps and find out which apps are allowed to connect. So by default, we're using this config file, but if you want to store them in the database or somewhere else, you can create your own provider implementation and swap this out in here. You can configure which hosts are actually allowed to connect to your server, so the allowed origins. Then what's really important for our package is you can define the maximum amount of payload that your WebSocket server should accept. You can change the path, some middleware, statistic information. If you want to host this, of course, you may want to use SSL for this. So here's also the ability to change the SSL settings. And yeah, so there's a lot that you can configure with our package. The Echo integration, it's still kind of easy. It's using pusher. Since we have a pusher replacement, we can just define that the broadcaster that we want to use is still going to be pusher. The key is then going to be whatever you defined in your config file. And then the official pusher JavaScript client allows us to override the host and port that we want to connect to. So then you can just define the host and port and point it to the WebSocket server host and port wherever you have that running. And last but not least, quite important, the disable stats. Because by default, the JavaScript pusher client is sending some statistical information over to pusher.com. But since we're not using pusher, we do not want to send this anyway. So you can just disable this. And as a demo, I'm using the plain old chat example in here. But what's cool is that if I'm going to open this up in a new tab, what we built is kind of similar to what pusher has. So let me just do it side by side so it makes it easier for you to see. And we have some kind of debug dashboard available. So once you install the package, you have this Laravel WebSockets route. You can change the path. And then you can see all the apps that you have defined in your config file. You can define the port, and then you can connect to your WebSocket server. So as you can see, we are now connected to our WebSocket server. And if I'm now, oh yeah, I'm still receiving all these tweets. Let me just disable this. Yep, I don't need this. And now what you can do is, if I just type something in here, we can see in real time coming in the events that we broadcast from our client, so from the browser to the WebSocket server. And then you can click on each individual event and see the payload, what happened in here. So every time I'm typing, we are emitting the client typing event and can see this coming in real time here. And now if I send this, I see an API message coming in. So internally, we also rebuild the pusher HTTP API that Laravel makes use of. And there we can see the payload of the event that was sent from our website to the server. And now what you can do is I can just copy this, paste this in here, make this a bit bigger, and then replay the event and modify things. So I can choose the channel. So this is present chat, and the event is called app events message sent. And now if I'm going to change this, like this, and then we can send this. And then we are just emitting events from our server to the WebSocket connection that we have open here. So just like this, similar to what you can do on Pusher's end, we have also support for the event creator and the debug of these events. Now, if you've used our package, you might have noticed that this hasn't worked before. So I implemented this a couple days before the talk, so this will go online in an upcoming update later today. All right. There are some pitfalls when you use the package, which boil down to the deployment. And that is called ulimit. So on Linux systems, what happens is that everything is basically a file. So when you open a new connection to your server, the Unix system will store this as a file reference to the web server. And by default, the server has a limit of 1024 files per process, which means that using our package and not modifying the ulimit, you would be limited to having a maximum concurrent users count of 1024. So you can overwrite this using the ulimit command, but this is only a temporary solution. So you can also override this by using a specific config file in etc security limits.d. So this might change depending on what kind of Linux system you're using, but you can at least store this somewhere so that this becomes a permanent solution. And under the hood, we're using Redshift, which is using React PHP, and the event loop that they use is also limited to 1024 concurrent connections. So you can get rid of this by just switching over to a extension that you can install using Peckle. So you can just install either EV or event, and then the React PHP thing will use this under the hood. So all you need to do is just install this extension and you're good to go. So when we built this, we were quite skeptical if this is going to scale well because it's PHP and, well, who knows? But it scales rather well. So this is a test that I've performed on a 2 GB of RAM DigitalOcean server. And we ended up having around 55,000 concurrent connections. Of course, you have to take this with a grain of salt, because so these connections were not sending a lot of events to each other. So if you have a heavy chat app, for example, and every connection is sending and broadcasting data to every other connected user, then this might vary, of course. But still, using a simple 2 GB server, you end up having a lot of concurrent connections, at least in the example that I took. And it's being used in ODIR. So ODIR has been mentioned in every talk so far, so well done. The monitoring service from Freek, and they are using this for their event monitoring as well. So I'm not sure if this happens right now, but from time to time, you see this number jump whenever they perform additional checks. And they're using our package now, I think, since early December, and have broadcasted millions of events using our package. And it's running in there safely since a couple months already now. And yeah, that's all I have. If you're interested in the package itself and how you can make use of the package, go check out the official documentation at the link below. Also, the package really contains a lot of gems. It's, I think, one of the best written packages that Frick and I put out. So it's very worth looking into the source code of the package. And Frick and I also wrote a blog post on how we actually built this thing. You can see that at Frick's blog. So if that's something for you, you might want to check this out as well. And last but not least, I have created this course called PHP Package Development, where I talk about how I am approaching package design and how you can learn package design for PHP and Laravel in specific. So you might want to check this out as well. And the Digital Swag has a $10 coupon for this. So yeah, I will be hanging out in the chat section all day long. So if you have any questions, just tweet at me or ask them there, and I will try to reply to all of them later.
All right, that was awesome.
Thanks.
Just a couple little follow-ups people had. I think these are probably quick ones. There was one question about if your package supports Redis, which I think you said it does, right?
I know. There's an open pull request because right now it's not possible to horizontally scale the WebSocket package because it stores all the connections in memory. And there's an open pull request to make use of Redis as well, which I think is just not finalized yet. So once that's done, you can also horizontally scale the WebSocket server. Yeah.
Okay, awesome. And then just another, I guess, question on if you would be doing like a socket IO implementation.
That's what I wanted to do at first, but the socket IO is using some weird, it's not using WebSocket, the protocol. So that's why we didn't do this. And the socket IO protocol is very poorly documented. So that's why we chose to use Pusher instead.
Okay, awesome.
Okay.
Well, thanks a lot. Thanks for hanging out in the chat later.
Yeah, thanks for having me.
You can follow up there. If you guys have questions, make sure you get those posted. And what we're going to do now is take a break until 12:15 Eastern time, which is about another 25 minutes. And so everybody can get up, get a drink, hang out,